Welcome again, ReactJS 26. I'm Claudia, software engineer at YLD. It's actually my second time here hosting this event, and some of you may ask, why are you doing that again? It's actually quite painful, I have to say, because I'm a software engineer, and like many of you, I really love just being in front of my laptop with my intimacy with visual code and just be me and him. But it's actually, I was pleased to be asked to do this again because the first time it was so nice. Like I came here thinking, oh, frightened, stage, everything. I need to present in front of so many people. But I ended up realizing very quickly that it was such an easy peasy event, like with a friendly environment and, just people getting together with the genuine will to learn something about React. So it's really just a community of developers and designers or anyone interested in topics around React that get together on an evening to basically learn something new, share opinions, and do some healthy networking. So thank you all for coming. I think I would like to start by thanking whoever organizes this and sponsors this, because otherwise events like these, like open source events like this, wouldn't happen. So thank you, YLD, for organizing this event. If you're interested in coming back, this happens more or less on a quarterly basis. So next event will be early next year. Thank you especially to Victoria, Christine, Lauren, Sergio, anyone who is involved in the backstage, because it's a hard task. There's a lot of effort put into it, so thank you. And thank you to NewDay for hosting us today and for sponsoring this event. And to the speakers, of course, because without their knowledge, this would make no sense. And also to all the attendees, because we could be here speaking, but without someone listening, also it wouldn't make no sense. So thank you all for coming. Here we go. So as I said, Claudia from YLD, I'm a software engineer. I also do code in React. So I'm genuinely interested in the talks today. I would like to remark that this event is actually, it's the 26th edition, and it's nice also to see that there's a lot of people coming back to assist it. And this is a way for us to reach the community and to share some knowledge. And we even got a prize out of it, actually. We got the React Open Source Awards. We went to the React Open Source Award ceremony, and we got the most impactful contribution to the community last year. So we're really proud of it, and we hope to keep going with this event more and more. So just a little bit of quick information. We're going to have a first talk at 6:45. Elham Khani will present as Elevate Maintainability of your code by following solid principles. 7:15, we'll have a second talk about Memoization by Beth, Swingler. We will then have a short break of 30 minutes where we can do some networking and enjoy some food and drinks. And we'll be back for the third talk of Rachel Nabors at 8:15. 8:45, we'll be wrapping up. And at 9 p.m., we are closing the event. But if you're keen to do some networking, we're going for a drink at the Star of Kings, which should be right next door. So just about some logistics. So the format today will be a little bit different from other events we made. If you're coming back, you might not be used to it. But what we will be doing is each presentation will last about 15 minutes. Then we'll have 10 minutes for question and answers. We have multiple ways you can make questions. You can either just voluntarily put your hand up, and one of my colleagues, probably Victoria, will come with a microphone and help you out with it. Or we also have access to Slido, which is a platform you can go through that QR code that is at the very top, but don't worry, I'll give you a bigger size of it laterwards. You can type your questions there. By default, they are anonymous, so if you feel shy, you don't want to put your hand up and make a question in front of everyone, please do it through Slido, and I will read them at the end of each presentation. Just be nice in terms of, code of conduct, let's be nice. Let's not say names and stuff, but we all know that. Just wanted to point out that this event, for us, is very important for sharing, spreading information about this event. So if you, for example, are keen to come to the next one, or you want to add a comment or a post about it, you can follow us in our LinkedIn page. We also have a YLD Instagram page. And please do, if you wish, to tag us in one of your comments, just use the tags that are up there. ReactJS Girl, YLDIO, ReactJS Girls. Yeah. Here's the magic QR code. So this QR code will give you a lot of power. You can go to Slido and make questions through it. You can follow us. You can join our community. If you wish to rewatch this video, we'll be posting it on YouTube, and you can access the video recordings through the QR code, or if you want to share it with some friends or developers that are interested in the topics, or if you want to find out about WildD or investigate some of our openings. So before starting, I want to give a couple of minutes to our organizer and sponsors to come here. I would like to welcome them here at the stage and talk to us about a little bit about WildD and NewDay. So I would like to ask Alec to please join us in the stage.
Good evening, everyone, and welcome to ReactJS Girls. So I'm Alex. I'm one of the talent partners here at YLD. So just to give you a bit of information about who we are. So we are a engineering and design consultancy, and we work with many different clients, NewDay actually being one of them. So it's really great to partner with our client on this event. But we work with people like The Economist, Trainline, Auth0, GoDaddy, and many, many more. And we work with them very closely. We build that partnership up, integrate with their teams, and just help them make great products. And being a talent partner, I'd be silly not to say that we are always looking for talented individuals. So if anybody's looking for a new role, please feel free to come and speak to me or reach out to me on maybe LinkedIn, or anybody that's wearing a YLD top as well. But hope you enjoy the evening.
Thank you so much, Alec. I've just been warned that I did something wrong, so I should have put the slides on. We're inviting here now Kitty from NewDay to actually talk about a little bit some logistics.
Hello, everyone. Just a bit of an introduction into who we are. So NewDay is a credit provider. So our purpose is to help people move forward with credit. So we're a purposeless business, and we believe in credit as a force for good. We've got over 5 million customers. You might be familiar with some of our brands. So these are some of our brands and our partners. So Aqua credit card, BIP credit card, the John Lewis credit card, those are all powered by NewDay. So we've got some very, very, very intelligent tech minds behind some of the products that we offer and that we support our customers with. We also are hiring. If you're interested in any of our roles, or want to find out more about the sort of roles that NewDay has to offer, please scan the QR code. It will take you to a general page where you can just register your interest. So it doesn't mean you're committed to any particular role, but you can just register your interest to find out more. And these are some of the roles that we've got open in tech at the moment. I think that's everything from me. So I will now hand over to Elham.
Thank you. All right, so let's start. I'm going to call here Elham Khani. I'm just going to give a bit of an introduction to this rock star because Elham is just, wow. Elham started as a web developer 15 years ago. Then she embraced more of a full stack profile and then became a tech lead and is now an engineer manager here at NewDay. I have the actual super pleasure to work with her. She's great to work with, has a lot to share to us, and she will actually tell us a little bit today about, that saying, an apple a day keeps a doctor away. But how many of you actually eat an apple a day? Well, actually, it's more than what I thought. I think I eat one per year or something. So she's gonna actually tell us a little bit about solid principles and how we should use them in our code to be healthy, to have a healthy code.
Okay, hello, I'm Elham, and I'm going to talk about solid principles, and hopefully it's not going to be too boring. So, solid principles were coined by a guy called Robert Martin, or Uncle Bob. It's been decades that these principles exist. And Mr. Martin is one of the guys that who signed Agile Manifesto, which I think is very cool. And he has lots of talks and books about clean code. The main problem that we're seeing in software development, and I like to call it the devil of software programming, is dependency. So when you ask to change a bit of code, one of the problems in software programming, one of the big problems is dependency. So you are asked to change a bit of code, and it requires changing multiple places. It requires asking other team members to change their code, other teams to change their code. Sometimes it gets so big and unmanageable that you decide to rewrite the whole thing. And this is because most of the time we create a code in a way that there are lots of dependencies there. And solid principles are trying to solve that. As Claudia said, it's a healthy kind of way of coding, but it's a guidance. It's not a rule. These set of principles are not for following like a rule. It's like 10,000 steps per day, okay? If you do it, it's a healthy practice, but it's not going to solve all your problems, but it's good. So these are the list of these. We're going to go through them, but few things to notice. One is that these order, they are in this order just because that Mr. Martin thought that having it as solid is nice. So there's no order here. And also, the way that we look at dependency is about how in future we can change our code. But there is a limit about how much we can predict future. You cannot have a complete, flexible, extendable, maintainable code. So always there is a limit, and have that in mind. Also, even in theory, you cannot apply any of these 100% in your code. It doesn't have any meaning. For example, you cannot have single responsibility 100% in your code. There's going to be one index.js file that you need to put few things there. So many benefits. Maintainability, testing, because it's going to help you to decouple all these things. Reusability, it's going to make your life really, really easy. When I was thinking about presenting this, I thought, let's find a piece of code that I can apply these principles one step at a time. And I thought about a pet project that I had. I wrote it in a couple of hours, and it's about giving OpenAI 3 keywords, and it's going to create a greeting card. For example, a birthday card. You say, I want a birthday, I want the theme to be happy. You can use a scary or anything there. And I want to have a cat in it. And it generates something like this. So cool. Because I wrote this in a couple of hours, obviously it's unmaintainable, it's ugly. So let's go through the solid principles one by one and see how we can improve that code. First one is easy. Single responsibility principle. So just have one responsibility for each piece of entity, code, whatever that you want to call it, module. This is a part of my code that's doing the main job. I'm calling OpenAI 2 times. The top one is calling the chat, which is going to generate that text, the birthday message. And the bottom one is calling the images and creating that cute little thing. So easy. I just need to separate them. That's going to be giving responsibility, one responsibility to the entity. You can use this guidance a lot in your code, and that makes life more maintainable. The second principle is a really good one as well, and that's about open-close principle. Open to extension, close to modification. What does it mean? It means your code needs to be written in a way that if your product owner comes and asks you, can we add $E2 as well? You don't need to go and change the code. You can just add something to your code. You can extend it. It is open to extension without need to modification. So let's look at my code. So I'm having these two models using GPT-3 and E3. What if I want to use E2? I need to change my code. What's going to happen? I'm going to lose E3. So this is not extension. This is modification. How can I solve it? Abstraction. So abstraction is the tool that you can use a lot. You can have an AI model at the top and saying that GPT-3 is the abstraction, extending that AI model, and then using it when you are calling, and it's going to be all good, pretty, but I was lying. So when I applied the open close, I could see that now I have two classes, two modules. One of them is an image one of them is text, but both of them have two methods in them for both chat and image. But the DAL-E doesn't need to know about the chat. The chat doesn't need to know about the image. So what we're going to do, if you haven't seen this movie, Big Lebowski, go and watch it. So use interface segregation principle, but it's the fourth one, so I'm going to skip it. Have that picture in mind that we did something wrong. We need to refactor. We get back to it. Let's go to the third principle. This is an interesting one. Liskov substitution. Miss or Mrs. Liskov, who did this, if you read the principle, it's a mathematical equation. It's very difficult to think about it. And it says all derived classes must be substitutable for their base classes. Again, a little bit weird. So the way I want to show is this. Imagine that I have one class AI model, two models, text model, image model, GPT-3, GPT-4. You know when you're typing in ChatGPT and it writes down for you, it's not like that because it's pretty. It's because there's a problem in OpenAI. It is heavy. The text models in OpenAI works in a way that when you ask for a text, when it is generating, it has to put back the generated text back to the model to generate the text next part, back again and back again. So when you call OpenAI, it might take 20 seconds to give you. So they said, we're going to do a streaming. You can ask for chunk of the text and get that and present it. So it has some technical benefits and also some UX benefits as well. If I want to use this streaming, if I put it at the top one, and when I say put, it's a behavior, so it's a method. If I put it at the top, it's wrong based off Liskov because the image model doesn't need to have it. And the correct way of doing it is putting it in text. So there are some symptoms you can look for in your code to find out if something is a bit odd. Maybe you are violating Liskov. For example, if you're seeing, when you are code reviewing someone's code, someone is using if statement to mask behavior of the parent class or module component. That shows that it shouldn't be, that behavior shouldn't have been in the parent at all. So something's wrong. So this is a symptom. It doesn't mean that definitely they are violating this. The other one is when you are throwing an exception, but doing nothing about it. I find it really funny when there is an expected exception. There shouldn't be any expected exception. So usually, or maybe, it shows that the Liskov principle is violated. And if you know it, you might be able to do something about it. So remember the mistake that I did? And I got there, and dude was telling me use interface segregation principle. It's very similar to single responsibility principle. And that's fine, because all these dependencies we are talking about, It's about making less dependency. So if we are repeating ourselves or these things overlapping, it's fine. Let's apply it. I have these two models, and they're having methods that seems wrong. So easy. Again, use abstraction. We have one text AI model and one image AI model. And I'm going to use the text, my GPT model, extending the text model, and DAL-E model extending the image AI model. Then, OK, later on, you're going to see how it's used. One of the things, when we're getting in this kind of area, one of the issues I'm hearing from developers is that, but we are writing so much code. So it was 10 lines of code, and now we're having 5 files, and we're having so many classes, and we have to write all the tests for those ones. So our code is getting bigger and bigger, but that's fine, because instead of having a heap of code that is not manageable, now we are organizing them. So if we're having more files, if we're having more modules, that's not a bad thing. It just means that our code is more maintainable. Last one. So dependency inversion principle. These principles are coming from object-oriented, and some of them might seem a little bit hard. The whole idea is that if you have high-level modules, whatever that you have, classes, components, they shouldn't be dependent on the lower one. Example in my code. So this is the main React file of the code that I have. In the submit, I'm calling my API. I'm getting the response. The response is a bit ugly. I'm setting the message and image at the bottom of it to show that this is the content and this is the image. But you can see that there is at least, even if you don't know this is a dependency inversion or whatever, you can see that there are too much dependencies here. Let's have less of it. So we're going to have API service, another service. Its job is only calling my API. Its job is creating a nice, beautiful return, a message, an image, and I'm going to feed it in to my homepage. The homepage is going to receive it, knows that this service, I have no idea how it creates that object. It's going to give me a message, and it's going to give me an image. See how easy it is to mock this and work with it and write tests for it? But the other one, the whole API working with that would be really difficult. So how much time do I have? OK, so I can show the code itself. You don't need to look at the code. The structure is more important if the code is too small. So now, in our models, we have these, in the model folder, we have these files, and each one of them is one of our models. So you can see that now I can have DAL-E2, and also I can have DAL-E3. I didn't need to delete one. In DAL-E or DAL-E3 or DAL-E2, doesn't matter. The idea is that now we can have any models that we want and then give it to our API service. And our API service, the Open API service, is just thinking about text model or image model. So it doesn't matter which one it is. And only I need to change where the image model or text model coming to use it. So if I change my image model to DAL-E2, it's going to use that. And if I use another text model like GPT-4, it's going to use that one. And that's going to be the benefit. I'm sure this code can be refactored again and again. There's an extent that you want to predict the future, but at least I can sleep a little bit easier when I'm having this code. Cool. Thank you very much. And that was about solid principles.
you think that some of the rules of hooks actually try and enforce certain responsibility principles? But for example, like you can't put a hook within an if statement.
I do think so. Yeah. The whole idea about these kind of principles, I was talking to Lucas just before this about design patterns. These are a little bit like I would like to say it's a philosophical questions about the programming. And when you know about them, you can see them, these behavior every place and see that, oh yeah, some of this is getting applied here and there. And yeah, I do think that that is what's happening behind the scene.
I actually have got one.
Okay.
So if you looking at these solid principles and looking at your experience reviewing code and looking at other developers' work, which of these principles you think is the least applied?
Okay, you want to me name the least favorite child?
Yeah,
Okay.
the one we drop onto more.
The one that can, I don't know,
Yeah.
not gonna send to boarding school. Okay. I think the list of one is the most difficult one to understand, but it doesn't mean it's the least favorite. When you apply it, you see the difference. So by its own, it's a bit, what does it mean? But it's about what happens next when you apply it, that it changes your code. So I've seen at least been talked at least about. And it's one of those ones that been asked a lot in the interviews, just because people know when you ask them what's the single responsibility, everyone can guess. But when you say Liskov, everyone just panics and they don't know what it can be. Yeah.
Yeah, the name is not
Yeah.
straightforward.
Yeah.
Okay. I actually have another curiosity. Is there anyone that wants to make another question, or can I go ahead with mine? All right. So refactoring could be an endless task. Like we could pick up our code and be days refactoring it to make it perfect. So what would it be your advice to set a rule, say, okay, refactor following these guidelines, but at some stage you need to stop?
First, if you do it a lot. So yeah, I've seen a lot of developers, they love the refactoring, and that's absolutely fine. But I've seen many developers are complaining about the other developers, saying that these developers are refactoring too much. Okay, so what's that level that you can say that, okay, that's enough of refactoring? I think that point about predicting the future is very important. You cannot predict your future in even 2 years. So ask someone, instead of, as a developer, sometimes we don't know the answer. So ask your project manager, your UX designer, to give you an idea that what is their vision and work based on that. And also think about a little bit ahead, not too far. It's like when you are driving at night with your lights and you always see only a little bit further, and just knowing that bit is enough. You don't need to know the whole road to the end, but every little one is enough. So you refactor 2 meters, is that good to say? And then after a while, you feel like that you can refactor a bit more as well, then do it. But don't think that from the beginning or while you're working something, you can refactor it to the perfection. Such a thing, to me, doesn't exist.
Fair enough. Also because we don't know how we're going to use our application in the long future. So we are also kind of like guessing how to refactor things without really knowing what we will need them for.
Yeah. What I'm trying to say is that guess, but guess in kind of a limited, foreseeable scope. Don't think that you can guess everything. Probably you are overdoing it.
Good. Thank you. Any more questions? Sounds like we have some Slido question. Let's check this out. All right, so for practicing Solid, should we learn these principles with Java or some other language before applying these to React UI?
Don't even do that. Have that in mind, that such a thing exists. And when you are looking at the code, like I don't know, a detective, like someone who's looking at something interesting. It should be interesting to you. Look at it and say that, am I seeing dependencies? Is there code having problems with writing tests? Is there any problem with extending this? And then while you're looking at it, then think that, okay, there were some solid principles that I know a little bit about it. Go and check them and see if you can apply them. Don't go and learn, what was the language? Java?
Java.
Yeah, don't go and learn Java to understand solid principles. Solid principle is not about any language. It's a kind of a concept, okay? So you just learn how to not have dependencies, and doesn't need to be applied to your React code. It's just when you're writing your code and you have, for example, a list of items, and in the list there is a component, you think that, can I extend this? Can I use another component in this list? If I cannot, is it because, I don't know, I've heard about, I don't know, single responsibility. I'm saying it a lot, I know, but can it be a guidance for me to go and fix the issue with that knowledge? It's not about any language.
General guidelines about coding, independently of what it is, pretty much.
It is started from object-oriented, and obviously C#, object-oriented, C++, those are the kind of the beginning of the whole thing. But yeah, it's not about any language.
Do we have time for one more? Okay, so do solid principles lead to code that is abstracted out, but which increases cognitive load? Is there a principle to keep engineering cognitive load low?
Okay, can someone explain to me what is cognitive load? Okay, go on, the man self.
Cognitive load is where the total sum of effort it takes to comprehend a piece of code you're looking at is increased because of the number of moving parts rather than reduced.
Okay, that's a very good definition. I like that. And okay, can we measure it, have a code, measure it, and apply it? I'm guessing someone has done that.
Generally, the measures that you would use to identify cognitive load are things like cyclometric complexity, which, if you've not heard that very, very long and hard to spell word before, is the number of nested conditionals down a particular code path. There's a bunch of shitty approximations of that you can use as well that are kind of okay. And the amount of abstraction that any one piece of code is exposed to. So you can measure it, but it's difficult.
Okay, so I just thought about a kind of a measurement of my own. If you refactor your code and explain it to your good friend who's a developer, and they say it's a shit code, accept it, okay? Don't go and say that, no, I did it based on solid principles, and definitely it's good. Don't go that way. That's going to be my measure. If I give it to another developer and they say, it's not really readable, I am absolutely lost, after you even explained it to me, I'm saying that we're going the wrong way. That's my way of handling that.
I'm going to give you this one for free. You get one of these in every talk. It depends. Just say it depends and drop the mic.
I never gonna say it depends because I'm against dependency.
All right, one more question.
Okay.
Last one, I promise.
Thank you.
Do you recommend any automation tools that can enforce solid principle on pull requests?
You think that I didn't do Copilot for it? I did. It didn't work out. No. So I hope that at some point it's going to work, but I used Copilot for every little bit of it and said, is this violating solid principles? And it was telling me that, no, it's not violating. I said, I'm seeing it. This is just right there. I can see. And I was saying, is it violating single responsibility or is it violating list scope? And it was telling me, no, and I don't have enough context. That was what Copilot was telling me. So I'm hoping at some point it's going to be easier. I'm all for automation. I'm all for having those kind of code analysis and all that. And I'm sure that there are definitely tools for it as well. but it's only my hope that it's going to be there.
For the time being, we will rely on us.
Yeah. What's the one with the, oh my God, it has a sharp in it. Anyone remembers the name?
Have some more hints? Do you have some more hints?
No. The code analyzer that ReSharper. Oh, thank you very much. ReSharper, I think it gives some hints, but I don't know anything for React or, those kind of frameworks. So an idea, if you want to create one, probably you can do.
Do we have time for one more? No. Okay. Well, thank you, Elham.
Yes.
Thank you for the
Thank you
great
very
talk.
much.
Now progress with the second talk of tonight. And while Beth gets ready, I will tell you a little story about her, because I think it's nice to know a little bit the background of the speakers. So Beth and I both work at Wildy. She's also a software engineer at Wildy. And we were at the company offsite recently. We're having a drink, just talking about what did you used to do before, joining Wildy. And she just started blah, 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 like 300 things. And at some stage I looked at her and was like, what are you, like 80 years old? Like, you don't have a lifetime to have done so much stuff. So I was really impressed. Like, she did loads of all sorts of stuff. So her background is in philosophy. Please correct me if I'm saying something wrong. She then took a master's in neurosciences. Then she decided, well, let's open a startup with my friend in an attic, and made basically a startup with a multi-million turnover. And then she decided to start coding, just like this. And now she's here with us today to talk about memoization. Should we use it? Do we abuse the use it, or should we forget it? So let's welcome Beth Swingler.
To get into it, I'm basically going to talk about memoization, something that if you work with React, you're either love or hate. So I'm going to cover the good, the bad, and the ugly. Then I'm going to touch on the new React compiler and explain what I see as the core lessons that we can actually learn from it. Well, at least from the little that we actually know so far. So, memoization. What is it? It's an optimization that involves storing data or a stable reference to a function in memory. Traditionally, it would be used for storing the result of like a complex calculation to speed it up. How would it speed it up? Well, every time you perform a complex calculation, it takes time. So rather than performing it every time, you can store the result of that computation in memory. So if you get the same inputs, it will just return you the stored result rather than recalculating. But remember, it's a trade-off. So it uses up space in order to save that time. So these are the classics in React that you'll be familiar with if you've been memoizing in React. Use memo, which is for data, memoizing data. Use callback, memoizes functions, and memo memoizes components. So what happens when you use these is basically it won't rerun them unless the things in the blue brackets, i.e. the dependency array, unless those values update. The dependency array is really useful. Number 1 and 2, memo and callback, have got an explicit dependency array, which gives you the power to say, only watch these values. And so it will only update if those values change. Number 3 has a kind of implicit dependency array, and those would be the props that are given to that component or its own internal state. And later we might come back to why number 3 isn't just always the case. Why not just wrap everything in a memo hook, but if we have time. So I thought, one thing you might be asking at this point is, I thought memoization was meant to be for calculating speeding up complex calculations. So why do we use it like this? This is probably a pattern that you've seen quite a lot. Well, in React, we use it like this, and we should, in fact, use it like this, at least for now, because what happens when you give an unmemoized object to a provider, say a context provider or a parent. As some of you will know painfully from experience, what happens is a hell of a lot of work that probably doesn't need to happen. And that's because in JavaScript, data in the form of objects, arrays, and functions do not have stable references. That means that they are created new every time. And so this object, if I made another one that was identical, still the key is X, still the value is user ID, which we're going to suppose is a string or a primitive of some kind, then even though it's the same, and philosophically, a separate debate, but it's not pointing to the same place in memory, so React doesn't consider it to be the same thing. JavaScript doesn't consider it to be the same thing. In other words, all non-primitive values are strictly identical only if they point to the same place in memory. So do use it like this because it will prevent all the subtrees from updating, because React re-renders all subtrees or subscribing components when a prop changes. So, as I said, the value prop is recreated on the fly every time this context provider re-renders. So even though this one's trivial and I could pass it exactly the same string, it's technically going to be a new object, and that will, if it's not memoized, that is. And so every component that subscribes to this, imagine it is the user ID, because that's like a really useful one where you do want everything to re-render if the user ID legitimately changes, so that you don't have all of your data showing to someone else's if they happen to then log in. But what you don't want is if your same ID comes up, every single child to re-render. I.e., when I say re-render, reruns all of those functions and all of those child functions. And that can be really expensive if you have a big tree like this one. So use memo lets us use space in order to solve this problem. Basically, the analogy in this instance would be needing to check every single bauble on this tree to verify whether it is the same tree as your tree, i.e. your tree, or whether it's someone else's, when instead you could just have a label on it that says your name, and then you know it's your tree, and you can just check that label, and then it's fine. Let's say JavaScript comes along, puts a new label on it, and you go, now I need to check every bauble again. But it's a new label, but if it still says your name, and that would be the reference, then it's still your tree, i.e. the relevant change to watch out for, the one that would be in the dependency array, is whether the name on the tag has changed. And so that's the only thing we actually want to watch out for. So re-rendering is bad, and memoization is great. Well, some re-rendering is bad, or at least it can be bad, especially if the tree is really complex. But memoization has a clear, simple, and very effective use. The former example being a really good one, i.e. memorize the value object high up in the tree. Specify the relevant changes you do want to watch out for, i.e. save on what are often called needless re-renders. But re-rendering itself can't be bad, because re-rendering is what makes your UI reactive, i.e. React. It's what allows user events to update in the first state, like the UI in the first place. So we have to be more precise. Basically, needless re-rendering is when React goes and checks everything in the tree, like all the baubles, when it doesn't actually need to, so nothing changes. It doesn't get given to anyone else in the end, i.e. the virtual DOM doesn't actually apply any changes in the end. So this final slide is actually, I would say, the more nuanced perspective to have on it. So Memo is great. It's true. It is awesome. So awesome that it's in fact easy to get obsessed with it. I mean, they gave us hooks, right? Let's just like hang everything on those, right? Surely we'll only get performance gains everywhere. Well, let's very quickly look at an example that shows why memoization can, it's an extreme example, I'm going to grant this. So basically, in this component, what should happen is I press the next line, and this is a poem, the last poem that I wrote many years ago, but it's cyclical and uses very few actual tokens of words, but that's a separate point. So when I click next line, the only thing that changes is the final line, and that is the desired behavior. It does this in a slightly unusual way, and this does happen in practice, but in this example it is quite contrived, where basically it's using a local mutation, and that local mutations are happening here, i.e. we're doing a push. And so this extended data variable is the one which is pointing to the first variable, and then it pushes the next line onto both. So these actually stay in sync. And this example is derived from one that I saw in one of the React Forget, one of the few React Forget explanations by the core team. And so I thought, let's have a look at how bad this can get. Basically, in general terms, mutation is like a form, pushing is a form of mutation, and so it would be impure. So here is a version of this component, which I'm going to say naively memoizes rather than logically memoizes. So what happens here, I click next line, and oh my God, it just keeps adding, and nothing's changing at the top, but we could go totally insane here. And yeah, there's definitely too many words. It's not even a poem anymore, arguably. So what's happening there, right? So here is my impure memoization. What happens here is that the two variables that were created, basically, we're just memoizing them, just putting them in a memo, right? This one is only watching for the intro changing because that's all it cares about. The second one is only watching for the initial data and the next line changing. I wish it would stop trying to define everything. So what happens here is essentially the first memoized variable or data just doesn't change. The second one, however, when the next line changes, does rerun. So this memo block does rerun. And so it's still pointing to the unchanging initial line or lines. And when we click get next line, it adds on, it pushes the new next line to the initial one, the previous one. And then it keeps doing that. So again, the new one, the first one has been mutated, doesn't change, but we just keep adding to it. And so that's clearly not what we want. I should mention that the reason why it adds on twice is just because it's in strict mode, and so everything re-renders double to try and actually weed out impurity like this. And so, yeah, the reason why this is wrong or buggy, because this is actually just a bug. This isn't just like use memo being a bit expensive. This is actually just like ruining the logic that you put in your initial component. And so essentially, it's ruining what was like fine local mutation. Local mutation isn't a problem if it's contained within a component, but in this example, it is. So then I made another pure version. And what happens when you click get next line here? Oh, just nothing changes. And that's because in this example, we're only showing the first line again, and we're telling it to recompute only if intro changes, and it just doesn't. So no matter how many times we click, it doesn't update. However, we still have a second data. So incidentally, I should mention that this one does work the way we intended it to. So in real life, I would use, well, something more like the extended data variable here rather than doing the internal mutation, but that's kind of not the focus at this point. So we can see that it can be a little bit dangerous. So maybe we shouldn't use it. And some people do think that we shouldn't use memoization almost ever, unless you have drastically poor performance, which I think is a little bit too strong, because as we saw before, there are clear cases where it can just be used at the top level. That context provider is probably not going to get, like, there's not going to be loads of extensions to the props of that provider that are really complex objects, hopefully. So there are good examples of just using it really well. So I think the moral of the story is memorize some things. You just have to remember what it's doing. It's caching data. So we need to be careful with the dependency array in particular. It's not always premature to optimize. You just have to memorize, like, with, thought. Except that it's also sometimes a little bit brittle, and the dependency array can break it. But we need to move on. So why do we care? The new compiler's coming. It's going to do all this automatically. And that's the really exciting thing, actually. And what is it that it's going to do? Well, for starters, automated memoization. Woo! What does that mean? Improved developer experience, because we write less code. That is the aim of our life, right? It also means improved user experience, i.e., we get improvements in the performance of our apps. They will be faster. So how's it doing it? Is it some kind of black magic? I mean, the source code isn't even public, so how can we understand anything about what it's actually going to do? Is it going to create bugs like the one that we saw before? Well, first of all, let's look at some first principles. What does it even mean to say a React compiler? What is a React compiler? And then we're going to look at some demos that the core team have given, which actually do show what it does under the hood. And that's really exciting, because I think there are a couple of lessons we can learn from the compiler if we let it. Yeah. So briefly, in general terms, a compiler basically converts some symbols into other symbols. The symbols it converts into are usually more basic symbols, uglier symbols, but they're symbols that the machine can understand more quickly. JavaScript compilation, in particular, is just in time. It takes your ES6 or React code and basically compiles it to a lower level and then immediately executes it. What's really important here is that the React compiler is doing static analysis on the source code. So it takes a whole document or a block of logic at build time, when it's static, and tries to predict the program behavior. That is what static analysis does. And so, in other words, it doesn't just look at it line by line and try and transpile it into some other code. It is doing a kind of something more fundamental. What we know about it is that it is a low-level compiler specifically for React, and that means that it understands the rules of React and basically how JavaScript works. And so it builds an internal representation of your code at build time. And by understanding it, it can compile it into lower level code that's more efficient, that the browser engine actually understands. So the few things that we have heard from the core team are really interesting. We know a little bit about what it's doing, thanks mainly to this one. I noticed a few interesting things that I would love to discuss at another point in this talk, but for now I'm just going to look at the big blue circle in the middle, which shows what it's actually doing under the hood. So let's see what it's doing and see what we can learn. Given this code, it looks at which is surprisingly similar to the code I was showing you earlier, but it basically looks at the logic that is contained in this case, a hook, as a whole. And so in this case, what it does is recognizes that there are three dependencies, there are three pieces of data that could change the behavior, i.e. the two props and the one variable inside the component that's actually being used. The one that wasn't being used you'll see in a second. So it creates memo cache, which is where the $0, 1, and 2 are for each of those. And then when it actually renders, it's just using really basic if-then logic or if-else logic, which is actually really quick to run and surprisingly easy to read. So it checks the props first. If they're unchanged, it recycles and shows the cache data, i.e. the cache value for X, which in my example is the intro line. And if either of those has changed, the props, then it recomputes them both of them. And the focus there being on is watching for both of them at the same time. So it's more similar to the pure version in the other example. So I'm just going to quickly look back at those examples so I can show you what I mean. So this one is correct because it's watching both of the relevant pieces of data. And I have actually taken it upon myself to rewrite this code in my forget memoized component. And this one is working just like the unmemoized version. And that means the behavior, i.e. the logic, is first and foremost correct. And so it looks like it's smarter than whoever wrote this impure code over here, which is fantastic news for us as developers. So what is the actual lesson here? Basically, take a step back from your code when you're about to memoize it and make sure you've got all of the relevant dependencies. I know there are linters for this, but like your brain is still good and still worth paying for on a day-to-day basis. So the second lesson, I think, is that it's not always just purity that you need, because in the example where the data was just not changing at all, it was pure, but it just wasn't, it didn't have the correct dependency array. So the main thing is that we should make sure that the UI is a function of its state and reflects its state accurately. And so, yeah, the lesson I took from this was basically take a step back, make sure you're covering the whole logic, but it's gonna do some amazing stuff and make your code quite ugly so you don't actually have to. So another really cool thing it does, better than humans again, is memoizing JSX elements and components. So for example, a React memo can also memoize a component, but there are things that it does which we wouldn't normally do, like using a use memo, the equivalent of using a use memo within a component in order to memoize another component that's relying on data within that component. So can we learn from the compiler in this example? Well, I've seen people online already starting to recommend that we imitate this in this way, i.e. loads of these use memos, and in the dots, just assume there's logic, and it returns components, header, sorted list, and link. Well, look at the state of this code, man. Like, definitely not idiomatic React. Definitely brittle, easy for someone else to change, for you to forget a dependency or put in, say, an object into the dependency array, which again would rerun everything. And it might even break the rules of hooks, I think, if the components are themselves calling other hooks in a dependent way, but we don't have time to discuss that. Remember, the compiler is going to make the code ugly, so you don't have to. So, limitations. I'm definitely up for this new compiler, if you can't tell. You could say hotly anticipating it, but it does have limitations. These are important because it impacts what we do now in preparation for that compiler. So, what it's not going to do is actually improve your logic. If you've introduced actual bugs by, for example, abusing memo, the compiler is not going to change that. It's not going to change the behavior of your component. It's going to assume that is the expected, anticipated behavior, and it's going to just optimize that behavior and make it really fast. So the logic is still going to be your job. Something else that is still your job is going to be basically composition. And this is like the final point that I want to really emphasize in this talk. React already gives you tools for, I forgot to, correct this sentence, but basically, React already gives you tools through composition to prevent excessive needless re-renders, and that's called same element reference. If you're not using component composition properly, the compiler is not going to add composition to your code. It's just going to be able to memorize things. That's the limitation of it, and that's kind of a good thing. But it's going to have a cost. Memoization has the cost we spoke about at the beginning, which is memory, using it to save time. So avoiding re-renders sometimes just requires you to really use React. What does this mean? Very quick demo of that. So basically, this is a component. Everything above the dashed line is what I'm calling a header. This contains 3 React patterns. The one at the top I'm going to call unidiomatic, because the React team keep talking about idiomatic React. So when I click on this, then you notice that the only thing that changes is the words at the very bottom. Everything in the header stays the same. What you can see in the logs here are all of the components that are re-rendering, because each component used in this example logs when it re-renders. So here we've got 3 components re-rendering every time I click. Seems a bit needless, right? Given that a few words are changing on each click and the color. So this is what I would call like a fairly classic, this parent doesn't even really need to exist. All the logic is contained in this component. Basically, we've got the state hooks, 2 of them, and so we're updating the line, toggling the blue, and we've got the purely visual wrapper here. So it looks like we're using some composition. So what's going wrong? If we're not sure, we might be tempted to just memoize everything. So let's look at the memoized version. I'm going to clear my log. I'm going to do some clicking. Yeah, still got some re-renders. How fun. Basically, what's happening here is that we've memoized everything. All of the functions are memoized. We've got a use callback here. We've got a visual wrapper, which is itself actually memoized, but it's still re-rendering both of them. That's not fun at all. So yeah, the main thing to look at here quickly is what I'm going to call the idiomatic version of React. Look, I click and one thing changes, the idiomatic organism. How nice. This is how it should work. How are we doing this? That's what you actually want to know. So in this parent component, grandparent component, you'll notice there is no state. I will share this at some point if anyone wants to look through it. Basically, all of the static components, the visual one, the header, they're all kept at this top level. And the state changing components, i.e. this parent one, contains all of the logic, but like none of the static stuff. So they're like nicely separated. The state is kept really close to the things that need it. People often think when you say keep state local, it means like keep it down somewhere in a leaf node, but it doesn't need to. It can mean keep it in a parent, but that parent only contains the things, and this is quite congruent with what Elham was saying, only contains the things that need to be updated. And what's good there is that these children, which gets passed down from the grandparent, React knows that they're staying static because of the like one-way data flow system in React. So props are read-only, and by just passing some of them forward, it knows they haven't updated. And so the only thing that needs to change is this conclusion. And then in this example, I didn't even need to memorize the purely visual wrapper because it just takes these static props and lets them kind of pass through it. So that's my final demo. You'll be pleased to know. I am. Basically, what I'm saying here is that we need to be really using React to get the most out of it. here's a few ways of doing that. Keeping state local, and definitely not mutating state, especially global state, like variables outside of your components should not be updated from within your component. All these things are going to trigger horrible re-renders, as are classes. Sorry, I just hate them. And so my main point in this talk is basically, I think there's a reason why the Meta core team have come out every time they speak about the React compiler, they're talking about idiomatic React at the same time. And that is because to get the most out of the compiler, you're going to need to be writing idiomatic React. It has never been more important. React has this data flow for a reason. Make use of it. It makes your components predictable by machines and humans, i.e., the logical flow is obvious if you're using it correctly. Modern React, unlike old school React, has fewer degrees of freedom. It's been pursuing a pure functional model where it's just functions calling other functions, right? That lends itself really well to static analysis. And it also lends itself really well to like working with your colleagues, I think. Basically, the reason why, what makes unpredictable code is impure functions, which cannot be easily analyzed by humans or machines because there's no logical order to those. So using idiomatic composition now will benefit you and the compiler. And idiomatic React, i.e. good composition and use of props, is going to be something which you can do right now and will still be relevant because, like I said before, the compiler is not going to actually do that for you. We can use these same element references. There's some really good talks just about that, which will actually prevent re-renders at least as effectively, as I hope I showed in the previous example, as memoizing things can. So often it's not even memoization which causes problems, it's actually use memo, but this is a rant for a totally separate talk. To conclude, finally, the React compiler is still a way off, so let's recap on what you can do now to optimize your code. Basically, first, check that your memoization is valid. Take a step back, look at the whole logic of what you're memoizing. And this will give you a cue about what exactly you need to watch out for. What is the relevant name tag on your tree that will mean you don't need to check every single bauble. The upcoming compiler can only raise the performance of your app. It can't fix any bugs. It's probably not going to create any, though, unlike you. Memoize at the highest level. That's takeaway number 2. And this is because, like, basically, you shouldn't waste your time tinkering with the low-level components that have loads of props. People are going to really easily send an empty array or something to it, break the whole memoization in the first place. Also, if they're not re-rendering that many things, it's just not that important. Memoize the top-level expensive things that have trees below them that are going to be doing a lot of rendering work and slowing down your app. So don't sweat the small stuff. And finally, use React idiomatically. Localize state at the bottom and compose static components up at the top. So you might not need a compiler to forget memoizing if you can forget about memoizing all for yourself. And the best part is that these things will benefit you and your team and the compiler. So when it does come along, finally, to auto-memorize our components. So thank you. I definitely went over time, so I'm sorry.
Thank you, Beth. We did tiny little bit went out of time. It's fine. It's okay. We have time for a couple of questions, though, but good presentation. I'm just going to pop on this side, so I won't steal your thunder. So is there anyone that wants to make a question?
Not even where are all the images from?
Okay, I'm going to go for the Slido ones then. In computer science, caching is considered one of the most complex concepts. Memoization is a caching technique. How to learn memoization if you are new to React?
I mean, to link up with the next talk, I would actually say check out the new docs. They are just incredible. They explain how to do it in a very not academic or pretentious way, like how you can do it right now in simple ways in your React code, you know? And I would just I suppose not be too scared about doing it either. Like create a sandbox, play around with things, see what updates and what doesn't update. Like there isn't that much risk. There is potential inefficiency that can come from basically the dependency array. Like you're telling React to check the dependency array and that nothing in that has changed as well. So if you use it too much, it could make things ironically a little bit slower because React might do extra checking of those dependencies, which it might not actually need to do. But you'll notice if you've created huge inefficiency whilst trying to optimize, I think. And those linters, man, they're great.
Okay, thank you. I'm going to go for the next one. Do you know if React team gave any hints on the build time cost of the new compiler for medium to large apps?
So yeah, it's actually interesting because what's really relevant for your users isn't build time so much as the download time of your bundle. And it looks like, because we'll be putting less code, I will be writing use memo, blah, 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 less. And you've had a very quick look at some of the code that it spews out. And that is really basic JavaScript. It looks like it might actually reduce the bundle size rather than increase it. So it might increase the build time, sure. But you're not going to, what you don't want is the bundle size to increase, because that's what would prevent people with lower level devices or poor connectivity from actually downloading your JavaScript, app in the first place.
All right, thank you. Any more questions? If there's no more, there is one. Sorry. One more. There's a micro coming to your way.
Thanks, first of all, for the talk. It was very insightful. In the impure memoization example, I did not quite get why it was entering, it was adding things twice. Is it because of strict mode? Because I've not really managed to read the code. It's too far away.
No.
So is it because strict mode, I know it renders things twice?
So the impure one. Yeah, so I actually was a bit confused by that myself, and then I realized it's just, so when you're in development mode, i.e. with strict mode turned on, then it just automatically runs everything twice to flush out impurities.
Not something else, right?
Huh?
So it's because of strict mode, not something else.
Yeah, so it isn't because, so and it's a really good question actually, because what is not happening is it's noticing that this first variable has changed and therefore running it again within itself, if that makes sense. Just because it's watching it, because it's a mutation. So it wouldn't be able to notice that change. It's not looking at the value and saying, oh, it's materially different, I should update. It's not that, unfortunately, JavaScript isn't that smart. So it just thinks, that it's pointing to the same thing. What would actually happen in production when you press next line is that it would just keep adding. It would say there are too many words in most poems, and then too many poems, rather than the duplication, which is just an artifact, which unfortunately makes this a little bit less clear as a demo, but at least makes it more powerful visually. Just look at this mess. Anyway, yeah, this one.
Okay, thank you.
We have a bit of a break here. We should be back at, Vic, please confirm me, 8:15 if I'm not wrong. Yeah? Okay, so let's do some networking. There's a couple of drinks here, some food, and I'll see you for the third talk at 8:15. So we're here back again, last talk for tonight. I have to say we had a hell of a good lineup for tonight in terms of talks. I'm very satisfied with it. And the last talk is going to be given by Rachel Nabors. So for those of you who don't know Rachel started her career when she was 14 years old, writing comics, got an award out of it, then decided to started a career as a front-end developer, wrote a book about UI animations. If you have the chance, check out their resume because it has some awesome projects there with great animations going on. It's really impressive. I was stalking it when preparing to React.js, and I really enjoyed watching out your projects. Then a lot here. Actually, worked as a technical program manager at AWS as a leader developer education initiatives, and was part of React core team, contributing to writing and illustrating the React.dev docs. And today, they are here to talk about a little bit of the story about the React.dev docs. So, welcome.
Hello there. I'm Rachel Lee Nabors. You heard my introduction, so I'm not going to go on about it. The only addition I would make to that is that I work for this awesome startup now. All you need to know is that I'm leading developer education there. I love teaching. Hands up, how many people have heard of Clerk before? Okay, how many of you are using Clerk? Okay, well, I got stickers. You're welcome to come get them from me. Anyway, all you need to know about Clerk is that if you need user authentication at any point in the development work that you're doing, leave that to us and go make awesome things. Few of us want to grow up to become authentication experts. Unless you want to become an authentication expert, check Clerk out. So, moving along. I used to be on the React core team before this and a few other things. I spent my pandemic working on the React documentation site. And actually, I also spent it a little bit on did you just go back? My God, these clickers. There we go. Now, I'm also curious, how many of you visit React.dev? Raise your hands. Okay, sweet. All right. And how many of you didn't realize React.dev is the React docs? All right, good. We had a good show. Okay. Now, before the pandemic, in the long ago time, I was looking for a new role, and I was really interested in Vue. And I noticed a lot of the women in my community were getting into Vue and Ember because they felt like they identified with those communities. But I noticed that all the six-figure jobs needed React experience. And I was like, I tried to learn React many times, and I kept falling short. I never could really get past the Webpack configuration. And it's been like 3 hours doing that, and I still don't have anything working. And I was just like, I don't understand this. And I was like, man, if only React were as easy to learn as Vue. More people like me would be getting six-figure jobs, and they'd be thought leaders, and they'd be amassing intergenerational wealth, and the world would be a better place, right? You know, like, that's a pretty cool lever to pull. So the next thing I did, was I was like, all right, I'm going to learn React. So I joined the React team in London in 2019 as a developer advocate / documentation engineer hybrid. Note to anyone in the audience considering joining large companies in hybrid roles, don't. It's just an HR nightmare when it comes to leveling and career ladders. Just make them pick a title for you and go with it. Anyway, my goal was to democratize React education for everyone so more people could get six-figure salaries, amass intergenerational wealth, and create the world that I wanted to live in. Thank you. So this is how I spent the pandemic. Ta-da. Built this with a few friends from the React community. Some who you may have heard of, some you may not have. I'll try to give them shout outs as we go along, but we only have so much time. And I'm a little behind schedule already. But as I joined Meta to work on React, which all my friends criticized me for because Meta is evil, but six-figure salaries for the masses, come on. Before I could work on React, Meta was like, first, spin all this straw into gold. That is to say, they said, turn around React Native's documentation first. Show us you can do the thing. I was like, well, okay. I didn't know anything about the React Native community. It's a mobile development community. It's not a front-end development community. The mobile development community, how many people here are mobile developers? Hello! Thank you for coming. We're all UI engineers. We are all equal, but that is not how the JavaScript and mobile engineering communities view each other. So I reached out and I was like, hi, friends. What do you want? And I learned some interesting things. More refresher material on React. So many people were coming into React Native and they did not know what React was. Something like 20%. I'll show you numbers. Additionally, They wanted more visual content. They wanted more in-depth content on specialized topics like security. And they wanted up-to-date component and API docs, which are kind of like your bread and butter of documentation. If your component and API docs are out of date, nobody can trust you. They wander off and do something else and won't look at you again for 2 years. True stories. And they wanted interactive code because if you ever spun up a mobile development environment, it takes a long time. So it's much nicer if you can just see the thing in the browser and then decide if that's the thing you want to move forward with before you commit to spinning up your environment. I ran some surveys and I learned some interesting facts. For instance, 41% of React Native developers do come from a mobile background, and they did not have React or JavaScript knowledge. So in the React Native docs, when it said, hey, you know, React Native is like React for native platforms, they'd be like, well, shoot, I guess I better go to the React docs. And then they look and React be like, React is a new JavaScript paradigm. They'd be like, well, shoot. And they'd go to the MDN docs and they'd start with learning JavaScript there. And I was like, well, shoot, that sounds terrible. So fixing for that, we built in literal context switchers to speak to learners' personal experiences, added a React refresher to help ramp people in who just didn't understand anything about React, and interactive code sandboxes courtesy of our friends at Expo. They created this lovely thing called a snack that you can embed on any website. And because the docs weren't built from source, they used to, but then they switched over to just Markdown, and people were still going and reading the old source code notes because they were better. It's sad. I ran a documentation drive with the community to sweep through and update all of those docs so that they would be correct and involved with source. Now, I even brought in some experts. I don't know if anyone here knows Katie Kremen. She's one of my favorite London React developers. She's super awesome. She wrote our security documentation, brought in those experts from the community to help patch the missing documentation. I added some colorful illustrations of my own that turned out to be pretty popular. ReactNative.dev launched July 23rd, 2020. Before this, it was like GitHub.io/Facebook/React. It was a long thing. It was very hard. So we started this .dev React convention with the launch of ReactNative.dev. So you can see the React docs story started all the way back with React Native. I love it. It's like two communities feeding into each other. This reboot lifted React Native's documentation rating by 70%. That's the number of people hitting thumbs up compared to thumbs down. So this is a pretty good lift. The whole effort took about 6 months total. There was no big bang. There was a blog post commemorating us getting to, it's good. I can move on to my next project. Now that I had proven in the tenets, it was time to move on to React's documentation. And it kicked off on May 27th, 2020, at the start of the pandemic. This is actually a real photo from my Kurzgesagt mindfulness journal. It says that I played StarCraft at work. That was how we survived the pandemic in those days. We played StarCraft and kicked off the React educational materials reboot. Lovely. And like with React Native, I came in feeling like, well, I'm in the front-end community, but I bet there's a lot of things I don't know about this community. Why don't we run some surveys? I love running surveys. And the results were, of course, similar to React Native. That surprised me. I learned lots of things about non-educational things that were also surprising. For instance, more women maintained at this time legacy class-based components code bases compared to men, which I think says something about who's taking what jobs where. But anyway, data analysis aside, function components first. People are like, why are we learning about classes? Does React not believe in hooks? Why do we have to go through 3 layers of navigation to find this? You gotta know the secret password and do a little dance. And I'm like, yeah, you're right. There were no hook references. Use ref, you have to dive super deep to find out where the dependencies should go in that function. I remember being very confused about that. And I was right here next to the core team. And I'm like, what? Where shouldn't a robot be doing this? Thank goodness for compilers. More visual content, and of course, interactive code, which was kind of unheard of in these days. It was something you only really saw on courseware training sites. So one day, I promise we followed the lockdown rules. This was during one of the intermissions where we were allowed to actually meet people. Dan and I met up, Dan Abramov, that is, and we started doodling. most of our conversations between Dan and I came about as doodles. And because of this, I made a new friend named React Head. React Head shows up in my doodles. I used to he was inspired by IKEA. So I'd be like, Dan, is this how state works? Okay, hang on. Dan, is this how state works? And this was how we communicated. And some of these visual metaphors ended up being canonized, and I inked them. You can see my cartooning background, and they live in the React docs to this day, hopefully making it easier to understand the React paradigms through clever metaphors. But the effort also culminated in a huge spreadsheet of new content that needed to be made. If this looks weird to you, this is how all books get written. The content for React.dev was very different from React.native.dev. React.native.dev reorganized the content that was already there, edited it, modified it. React.dev was 100% greenfield, burned down project. Oy. So we weren't editing what was there. We were building essentially a new book, and books take years to write. We went to beta December 8th, 2020. This was when we officially started sharing with the community. Launched with lots of fun illustrations, like I said, and a diagramming system by Maggie Appleton, another London resident you may have heard of, who's super cool, although less active in the React community these days. Anyway, Maggie did an amazing job of translating my awful doodles into these much better diagrams, and I think they're a lot easier for people to understand. There are also interactive sandboxes made using Code Sandbox. These were a real game changer, so much so when I first showed people demos of this site, they didn't realize they were editable. We had to make a few tweaks to make them look more like code editors because there were subtle, people thought they were like screenshots of code. It was hilarious. But good to see people have those aha moments when they started figuring out how it works. We also implemented something called retrieval practice. So you show that cramming information doesn't work. What makes new knowledge really stick is there's this book called Make It Stick, and it boils down to TLDR, practice that's spaced out, interleaved with other learning, and varied produces better mastery, longer retention, and more versatility. This is a nice way of saying all those pop quizzes your teacher gave you in school served a purpose. By making you quickly recall and use information, it wired the neurons in your brain. This is why the wonderful engineers I worked with at Meta could just look at the code on the screen, blur their eyes a little, and guess from the pattern what it was doing, because they'd had so many instances of reviewing that code at the last minute, at late nights, etc. They'd retrieved it so many times that it was boiled into their brain meat, so to speak. So we wanted to recreate that experience of having worked at a company and troubleshooted React code yourself into the docs directly. And that's what the sandboxes let us do. We shipped these little challenges, which really make the difference. Dan made most of these. And it's like having Dan sit there and be like, well, that's not quite right, to any solution you might come up with. These are non-blocking. You don't have to complete them to move through the documentation. But most people in user testing wanted to complete each of them because they were fun. But how did we know that any of this was actually working? Well, we asked real people. In alpha testing, yes, that's right, alpha testing. I used to be a UX person. I would invite people from the community to come in and look at the docs, but first they had to fill out a survey. And then when they were done looking at the survey, they had to, the documentation, they had to fill out another survey. And between the first survey and the second Thursday, testing participants were 3 times more likely to recommend the documentation, the new documentation, to the old. Huzzah! So, March 16th, 2023, the docs were mission complete. The tutorial had been added, the API references were completed, and it was ready to stop being a little banner across the top of ReactJS.org and start being React.dev. ReactJS.org still exists at legacy.reactjs.org. So those of you who are still working with classes, you can still find it. It's still there. It's not going to be updated or maintained unless there's some horrible doomsday security flaw or something, which isn't likely because it's just React. Come on. But it's still there. It's not going anywhere. But this is the new home with the new landing page, the React.dev. It has over 600 interactive examples. That's a testament to Dan's hard work. It also has examples that are written with an international audience in mind. I want to thank Sylvia Vargas, who's not here tonight, but she was one of the early community contributors who helped overwrite all of our kitten-based examples with ones that celebrate humanity's finest achievements. That is to say, cities, art, poets, etc. No Star Wars references. We are not in the habit of exporting American pop culture to the rest of the world on React Core. Facebook might do that, but not React. All right. But I want to point out that all of these things, the illustrations, the sandboxes, they were trialed in React Native's documentation. This is how we understood what was working and that we had a good idea that these same techniques were going to work for the 10 times larger audience of the React community. And the interesting thing is these went on to change how we approached React. And the React community helped us realize those changes at a scale that we wouldn't have been able to in the past. 8 million learners had access to these docs during the beta, and now everyone does. I hope that they help you in your React journey, and that we have more people from more backgrounds coming in and teaching and practicing React. If you want to talk about developer education, please come say hi. I did bring some stickers. All right, thank you so much.
Thank you, Rachel. Impressive. And we are eternally grateful for this because we can now have some good resources to look at when we have any doubt. So is there anyone in the audience that wants to make a question? Oh, nice. Can we get a micro to Elham, please? Right here.
Yeah. So the question is not about React.dev, it's about your experience. At NewDay, we suffer from documentation. We have a big problem. We have lots of documentation and we cannot find what we want. We know that we have to fix it. We don't know how. Can you give me a secret that I can apply and it's going to solve our problem, or it can give me my first step?
Well, documentation is a really tricky problem. I actually find it's how do I put this? Like, I've worked with large-scale documentation engineers and technical writers, and I have my own opinions. They aren't going to work everywhere. Right now, I work at a startup, and my spinning straw into gold at the startup is fix all this documentation. But it's a very different problem from the scaling documentation problems we had at AWS and the open source documentation problems we had on the React teams. Each docs problem is a new problem. It's like fighting a new battle. I should use fewer military metaphors. My family was a military family. But there are some different things you can do. Number one, you can hire some professional technical writers and documentation leaders. Like, that always helps. Number two, you could say, well, we should use DITA. If you've got like an IBM-sized pile of content, DITA, I forget what it stands for. It's like DITA. But the idea is basically you saw all of your information, and it's like dry for docs. It's super dry. You extract all the core concepts and the tutorials and all these things into little pieces, and then when you need to launch new documentation, you just zip it up and compile it on the fly. And it's used for things like owner manuals for Samsung because they got to generate a lot of them and update a lot of them. That's like in a mammoth scale. For people who are working at smaller scales, you typically want to go with something called diataxis. It basically breaks down, this isn't a longer version of the talk, but it breaks down all documents into like 4 flavors, starting with API references, then guides that show how to use the different references with each other, then tutorials, which will help people build something, and there's a defined outcome, step, step, step. And then finally, conceptual overviews, which is where you sit Dan Abramov down and say, no, tell me really, how does state work? And you write that down. So there's a couple of different approaches, but baking documentation processes into your support mechanisms, as well as your engineering release processes, is the first step. Also, conducting a very thorough content audit and sweep is something that you should do anytime someone is coming in to take over a documentation code base, or as I call it, the doc space. It was like a really loaded question. You gotta ask softer ones.
Any more questions from the audience? Oh, here we go.
What's your favorite part of that process? You talked about like various different parts about it. What's your favorite part that you really enjoyed and why?
Reading the feedback. I love it because every time we come to a page I've worked on, feedback's like, it's amazing. Even if my name isn't on it, I'm just like, yes, it's amazing. Yep, that's why you paid. But no, I'm kidding. I'm kidding. Actually, it is metrics. I like following the metrics because if you have your metrics set up for your docs, I'm a big metrics person, not just around docs, but around products in general. I have like a fail state where I know something isn't working for just about everything I do, including having a party. Like fewer than 3 people RSVP'd, it's a fail state, cancel it. Or like, how will I know that the new Google Home is a success with my family? I'll know because my partner is going to stop using their Bluetooth microphone. I mean, like that sort of thing. And with docs, it's good to see like a certain level of bounces on API references combined with copy paste. So if people come in, they quickly copy something and they leave the site, that's a success case for an API reference. And I love looking at a dashboard and being like, yes, the heartbeat of the documentation is good, all is well, nothing is on fire. That's the part I enjoy. The second part I enjoy is actually getting to talk with really cool engineers and coming in sort of like with a big vacuum and being like, all right, open wide, we're going to get this out of your head now. And we're going to get it into everyone else's head. I think like the things that I like doing the most is taking information from one engineer's mind and unlocking it into many other minds so that that information is no longer privileged or arcane. Everything is easy to understand if you break it down enough. I actually love ChatGPT for this because it's like having a big brother. They're not always right, or a big sister, but you can ask them to explain hard things over and over again. I'm kind of excited about where we could go with educational tools in the future using these new tools. I don't think they answer everything, but like I said, just getting the information from one person to everyone is still quite cumbersome. And with technical topics, we still have quite a bit of ways to go before we can just make it as instantaneous as playing a movie.
Thank you so much. That was great.
Talking about good feedback, I have good feedback here that I'm going to read to you, which is not a question, more like a gratitude. React.dev helped me understand React and hooks better. React.dev is truly great for learning. So, well done.
I'm glad to hear that. That's great.
And talking about ChatGPT, do you think AI will replace writing?
I mean, come on. I specialize in getting people's ideas on paper. AI still struggles just as badly as humans do. You're always going to need editors. Will editors be paid as well as others? I mean, this is genuinely a question. The strikes with the film artist guilds that's happening right now. It's not film artist guild. It's like, whatever. Sorry. The strikes in Hollywood right now are essentially around, is AI going to write scripts and then humans are going to be paid less to edit them? And I got to say, if you've looked at many Hollywood movies, you're like, yeah, these definitely feel like they were written by a bot. They're all the same. I mean, you show me something new that someone's... I see this as a challenge for humans to try harder, but it's a real question. What if we could just replace tech writers with bots? But if you've ever met a tech writer, and I've met many tech writers in my career, I don't consider myself a tech writer any more than a developer advocate, as I've never actually had that title. But I've met enough of them that I know the complaint is always, there's not enough of us. We can't keep up with the workload. All of this documentation is rotting and we don't know how to manage it. And I'm like, well, if we could just build the power tools and like put them in like a mecha suit so they could like run analysis across the docs and go in and like do point-based changes and generate the examples from source code. If we could just give them those tools, they could do their jobs and not burn out. So I think yes and no. Will the bots replace writers? Yes. Will they replace the really hard editorial parts that only humans can do? Not in the near future. Somebody still has to set the system up and somebody still has to curate it and grow it and guide it. So I'm hoping for more like the mecha suit future, where people who are burning out are actually able to do their jobs and feel good about it and ship something that isn't keeping them up at night, or they're constantly feeling like they're battling a fail state. And less that people will be replaced entirely, which I think is foolish, and you will definitely ship what you invest in.
Okay, thank you so much.
Thank you.
Is this working? Do we have room for a couple more questions? Are you up for it?
I am. I thought you were shooing me off stage there. Yeah, I'll keep talking.
We're running a bit late, but I think we can run 5 minutes late. Just a couple more. So there's another question here from the audience. Tutorials usually don't come with test suites. Thought production-ready code needs testing. Can TDD approach be used as a learning practice for React?
I love that. And I'm going to reiterate what I think I heard there, which was the examples that we see in tutorials are very rarely run through test suites like a person might develop in the wild. Well, there was actually a React, and I'm forgetting the URL name, but Jad Jorban, who I knew from my time in Amsterdam, made this really lovely interactive React tutorial that literally had you working through a code base and tests running, and you could only advance to the next part of the tutorial if you got one of the tests to pass. I really enjoyed that. It was beyond the technical implementation scope of the documentation, but I do think that there is room in the educational market for more methodology like that. It's just usually outside the budget of the teams that take on things like documentation.
Which are the toughest pages to build for React.dev? How did you and the team push through it?
Well, honestly, I think the hardest part was use refs. And Dan's not here to talk about it, but Dan tackled that one for a very long time. It's because React still doesn't do everything perfectly or well. And so there are a lot of escape hatches and foot guns that have to be explained. And I personally found that the level of explanations that we had to go through to make it grokkable felt like doing backflips, to the point where I started to question if React was really creating a better developer experience, or if it was a good developer experience up to a point and then it just became gymnastics. Those were the hardest, and I really have to commend Dan for pushing through. I think it really helped to run the documentation, the various essays, through internal audiences and then through external ones, to slowly finesse it to a scope and metaphor and a level of detail that would work for the community.
Thank you. Any more questions? Oh, we have one more. Can we? I need to ask my boss. Vic, can we have one more? Yeah, okay, good.
Thank you for making React.dev. I personally find it very useful, and I basically look at it every day. So my question is, so now React.dev is open source. How do you deal with the different kinds of contributions, people opinions on what should be in there, type of guides or corrections, etc.? Like one example is the React ecosystem is so vast. So people might add guide for this, guide for that, like just at the integration levels. And how do you decide, okay, I will accept this one or that one, or just, something like that?
That's a good question. Now, it should be mentioned, I no longer maintain those documents. So I have moved on to other challenging educational issues at other companies. So the React team is managing them, and I can't speak to their practices at this time. I know that it was always a bit of a struggle because the number one of pull requests we would get or issues we'd get on React stocks were, can you link to my course? Or can you link to this popular blog post I like that explains things in a way that's not sanctioned by the React core team because it's fundamentally flawed on some level? We'd get those a lot, and it was always like, what do we do with this? What label do we want to have for we see you? But we can't. I don't think we ever came up with a label for that. But all open source teams have a label for that. The trick is to figure out what it is. But for me on the projects I've worked on, what I try to do is workshop with community members who are using the actual product and the people who are working in support or on product to find out what the major use cases for the thing are. What are people trying to do? Where are they getting stuck? And then from this, create kind of a golden path roadmap for the content and try to hang the content off of that path, as opposed to just when I usually come into a doc space, it's like somebody just dumped things into the package, or they just like a bunch of people were creating guides and they just threw them in and hoped that they would land well. But a well-groomed doc space has a flow, a learning path, a lot like the one you saw with React compared to the one with React Native, which was more of a gardened learning path. The React learning path was very deliberate, and the lessons and the guides hung off of it with a very deliberate scope. I'm also a big believer in going with a nonlinear learning path because most people land on pages as they need them. And this is where the React docs go with a linear path. You kind of have to start at one end and work your way to the other. It's a little bit less dippable for reference, except for the API references themselves or the hooks references, as it were. But I like to make sure that each guide can stand alone. So if somebody's, for instance, the Clerk, just like, I want to add a sign-up form to my site, how do I do that? They don't have to go through an entire tutorial to understand the thought processes behind Clerk and how you should think about authentication. Like there's going to be material for that somewhere. But some people just want to get a job done. And usually documentation needs to be organized around that. So whenever people are making a contribution, the number one question to ask in that template is, what job is this doing for the person who's going to read this guide? Oftentimes, contributions are rehashes of existing content, or they are essays that have a nugget of something really useful in them, and your job as the person accepting that contribution is to work with the author to carve that nugget out and put it into a format that makes it easily digestible and consumable by the learner, rather than something they must endure.
Yeah, thank you.
All right. Well, thank you, Rachel, so much. I think we need to close it for tonight. Thank you so much.
Thank you so much for having me.
Thank you all. Thank you to all the speakers for having joined us and dedicated a bit of their time to open source. Let me just try. Keep going. Oh, here we go. So before we go, actually, let's do a little game. So many of you, I guess all of you, have picked up a number when you checked in early this afternoon. And we are going to pick up, I'm going to pick up 2 numbers here from this bag they just gave me, and the 2 lucky ones will receive a goodies bag from us. So I'm just going to do this now before we close up our nice evening. Where are the numbers? Oh. It's tiny. All right, so winner number 1 is number 109. Who has that? Yay, nice one. Where's the good? Oh, there you go. There's Victoria with your prize. And another one, another lucky one for tonight. Ooh. It's me. No. It's number 3. Who's that? Yay, nice one. Victoria is just behind you with your goodie bag. All right. So thank you. It was great. I really enjoyed it. I really enjoyed the talks. I think they were really insightful. We will come up with more ReactJS Girls events. They will come up probably early next year. So keep following our pages because we will probably announce it there. Not probably, we will. So yeah, Instagram pages. We also have our LinkedIn page you can look for. We also have another event coming up soon. It's on the 7th of December. So Design System London, also organized by WildD. Keep an eye on it. There's still perhaps a few tickets left if you want to participate. Just look for it. And if you cannot participate to this one, you're welcome to join the next one. What else to say? Well, thank you. You know, like all of this is only possible because someone is organizing it, someone is hosting us, someone is coming to speak at this event, someone is attending it. So looking forward to see the next ones. Thank you. Just one more thing. I hope I didn't say anything wrong. Last time I said we had a Facebook page, and it wasn't true. Facebook is for old people. I still have one. Anyway, we're going for drinks. That's the important part, no? I mean, if anyone wants to join for a drink and do some networking, we get to know each other. We can talk to our speakers there. If you have any curiosity, you want to keep going with some conversation, we're going to the Star of Kings. Thank you. It was written there. I just couldn't picture. So it's just next door, right? A short stroll, like fresh stroll. Yeah, we go all together. So yeah, that's it. I promise I've finished now. Thank you. Bye.